Thanks, everyone. So my name is Magnus Morton, and I'm a senior expert or principal engineer in the Edinburgh Programming Languages team and Huawei Research Centre, Edinburgh. And I've been there about 3 years now. I'm aware I'm the last thing standing between everyone and tea, so I will try and be quick, but there's quite a lot to go through. So I will cover three things in this presentation. First of all, a bit about the background of the details of Sanjay or CJ, and then I'll talk a bit about what we're doing in Edinburgh in terms of research and advanced development, and then I'll show you a bit about what it looks like to develop Sanjay on OpenHarmony. Okay, so just a bit of an overview of the programming languages situation in Huawei. Um, we have end user applications like mobile, IoT, cloud, and so on. And we have operating systems, we have hardware, and programming languages, compilers, and runtimes sort of ecosystem at Huawei sits between the operating system level and the end user applications. Um, so we're oriented towards industry. So motivation is performance and simplicity, semantic directed approaches, like using formal concurrency theory to inform what we're doing. And originally we had a intermediate level representation based on category theory and string diagrams. Also, we have done things like formalizing the language and mechanizing the proofs and so on. And this all informs what we're doing. And we have lots of academic collaborations with other universities. We have a lot of interns from academia. We have work with postdocs and fund postdocs and so on. Okay. And we have a significant research investment in the EU. Right. So a brief history of Sanjay. Sanjay project was initiated back in 2019, and it's grown over the years. But the sort of this year or last year, it was officially announced at Huawei Development Conference in Shenzhen, and you can now it's been sort of brewing internally at Huawei for a long time, but you can now uh, download and use it. Anyone in the world can. Um, yeah. Uh, so Sanjay is a general purpose programming language. It's I guess it's pitched at roughly the same level as Swift, Kotlin, and Go, but it covers a lot more ground, I would say, than those. So like all these features like algebraic data types, Java and Go don't have them. Unbox types, Java and Kotlin lack them. We have a garbage collector. We have lightweight concurrency. We have object-oriented programming. We have type extensions. We have actors as a built-in language feature and effect handlers. And I know a lot of people won't be familiar with what effect handlers actually are, but I will cover that later. So Sanjay has all the features you would expect from a general purpose programming language and quite a bit more as well, and covers a lot more than the other competing languages at the moment. So what does Sanjay aim to do? This is a sort of marketing slide you see on the website or whatever, but we want to be AI native. There's an inbuilt uh, agent-based DSL in the language. We want to be general purpose language with a fast, lightweight runtime, but usable anywhere. Want it to be a high performance language compared to other mobile languages, and we've measured significant performance improvements versus other programming languages in the same domain. And we want to have strong security in the DNA of the language, so memory safety, type safety, and runtime safety are all part of it through garbage collection, through the type system, through the runtime support as well. Okay, so what does Sanjay actually look like? So we start with the obligatory Hello World program. It looks very much like every other sort of programming language like Swift and Kotlin does. Not much difference. Oh, we do have full full Unicode support, of course. Um, with the Fibonacci function here, you can see a bit of what it looks like with what you with sort of functional style match and case statements. So this is pattern matching, like you'd see in something like Haskell and Scala, and we have good support for it here. It's quite succinct and nice to use. Um, yeah. More interesting features, we have first-class functions. So you can pass functions as arguments to other functions and call them. We have overloading, operator overloading. We have name parameters, default parameters, variable int parameters, like everything else does. But we also have some other features that are a bit more uncommon, like we have trailing lambdas as a syntactic feature, a bit like Swift, for example. So in this function at the bottom here, we're calling the function myIf takes a lambda as its last argument. Here we can call it with an explicit lambda, or we can use the trailing closure syntax. And as we'll see later with the OpenHarmony programming with Sanjay, this is extremely useful for building embedded domain-specific languages without having to re recourse to parsing or anything. Some more features. So we have nice syntax for loops. We have for loops with clauses in them. Um, we have inbuilt arrays and so on. We can rewrite it with sort of nice functional features. And we also have this stream operator I'm talking about here. We can use this to sort of pipeline functions together. So you have a nice set of tools for functional programming that are easy to use and good for building up DSLs and succinct programs. The concurrency story is probably one of Sanjay's biggest and best features. We have M10 lightweight threading model. So that means that we have lightweight green threads, which are cheap to construct and use, but they are mapped onto physical hardware threads. So you get the benefits of lightweight concurrency where it's cheap to create, but you actually get real true concurrency and true parallelism there. And again, the syntax is quite nice for this. We have the spawn keyword, and you just give it an arbitrary block of computation or a function call, and it just spawns a new thread and runs that, and returns. I'm binding it to a variable here, and that f there is a future which you can then get when you need it. So calling the get function on this will cause that to block, and the parent thread to block until the spawn thread is complete, and you get the resulting value from that. So this is quite a powerful feature. We got a very mature runtime for this. It's quite performant, and yeah, it's probably one of the best features in the language, I would say. We have a very rich macro system and support for metaprogramming in Cangjie. It's a bit difficult to grok at the first time you use it because it's not, macro systems are quite maybe not that common these days in programming languages, but what we get is you can define a macro that gets access to the token stream of the language, and you can arbitrarily rewrite functions, definitions, and so on using sort of classic macro features like quote and so on. So this is a simple macro which just decorates this function with some tracing information basically, and we're just reading the token stream, quoting it, and then adding some new stuff to it. I'm not showing this here, but you'd get full access to the AST at this level as well. You could parse these token streams, build an abstract syntax tree, pattern match on it, and then rewrite it as you feel like. So it's a very, very powerful feature, which is again very important for building domain-specific languages and that sort of thing, and is heavily used in the OpenHarmony side of Tanzit. Okay, I mentioned AI, and of course everything needs AI these days. So Sanjay has a native framework for AI, and we call this a multi-agent DSL. And I only have a sort of sneak preview of it. We have a domain-specific language for doing this using the macro system I just talked about. So you can specify a class as an agent, and you can specify the model you want to use. In this case, we're using DeepSeek. Um, we're using this prompt macro to specify the prompt we want it to do. In this case, we're saying it's the assistant to a cat. And if you see a mouse, you must catch it. Yeah, so you have your main method here, figure your API key, create your agent, and then you can just, there's a method called chat. You just pass your uh, anything to it, and it will give you a result. In this case, it will say, you print the result, it will say, so you say I saw a mouse, it'll print the result saying I've got a mouse. So yeah, you can use it to create multiple agents, and you can even have them talk to each other and so on. But yeah, this is one of the sort of more cutting edge features of the language. I've not really had much of a chance to play with it, so but we'll see where this goes. Okay, so I'll talk a bit about what we're doing in Edinburgh specifically. So Sanjay is a very large project. There are hundreds of people working on it in China and elsewhere. In Edinburgh, we're quite a small team. There's 10 of us working on this. So we have we concentrate in a few small areas of research and uh, and advanced features. So four features where we've been working on Edinburgh recently have been interpreter. We have an interpreter for Sanjay based on hypergraph rewriting. We have the compiler support. We have the intermediate representation based on string diagrams from category theory with an abstract interpreter optimizer. And we've been looking at effect handlers and actors in the language as well. And I'll be very quick. So I don't have much time to talk about this, but okay. So effect handlers are well-established area of research in programming languages, and we have support for them in OCaml as a first-class feature, and so semi-inspired features in React JS, which are kind of based on them. And we are very interested in the practical application of this. So we've had some previous work on effect handlers in C++ and effect handlers in C out of the Edinburgh lab, and we wanted to apply this to Sanjay. Um, so effect handlers are very similar to exceptions. You perform an effect, and then you can, like an exception, you throw an exception, and you handle it. But with effect handlers, you can then resume back to the point where the effect was thrown. So it's almost like an extension to exceptions. This is the syntax we've adopted in Sanjay. We use try handle instead of try catch. You try your computation, you perform an effect, you handle it, and then you can resume. So you can use it as an exception where you could change the error condition that produced it and then resume, or you could use it for scheduling. You could use it for pretty much anything. Okay, this is an example of using effect handlers. I don't really have time to do it. This is just an example for a very simple counting effect, but yeah. Um, okay, so the applications of this so far, we looked at scheduling, we looked at custom concurrency and coroutines, resumable exceptions, but we're looking very hard at this for aspect-oriented programming. It's very good for modifying functions and intercepting things and changing behavior, and also for reactive UI programming. We've also developed an experimental actor system for distributed computation and local concurrency as well. So the idea is that you could have a cloud edge computation and have it on your phone as well. And we have location transparent actors enforced by the type system. So we have one actor, and you don't really need to know where the other one is. You just call it like it's a class almost. You send a message using a special bang syntax. So you create an account here, send a message called deposit, and then you get the result as a concurrent future that you can access later. Okay, so Sanjay and OpenHarmony. So I talked a bit about the macros earlier. we have what we have for Sanjay and OpenHarmony right now is a component DSL for building UI trees. You you have reactive state management. You have yeah. So like what we have here, this is a standard Sanjay and OpenHarmony application. Basically, well, a view. You define your component with a macro. You define your state variables that will change throughout the course of the application with more macros. And then you define the UI tree. In a DSL, it looks very much like other modern UI DSLs. You have columns, lists, and then you have control flow as well in the DSL. And what will happen is this will be compiled and rendered on the phone. And when your state variables change, that triggers updates the in the application. So yeah. So the component DSL is the most interesting part of this from the Cangjie point of view. This relies heavily on the macro system we talked about earlier and also the trailing closure syntax, which gives you a very succinct and readable DSL and easy for the user to produce and translate from other frameworks, which is very important when you're talking about a new ecosystem with a new language and so on, and you want people to adopt it. The state management stuff is quite interesting. So it does not show up very well on the with the lighting here. So we have a list item which is editable and bound to a state variable. When we change the text on the item here, that will trigger an update to the state variable, and that will cascade down and trigger updates because the state variable is an array in all the other related components and so on. And we have multiple ways of handling this with different macros. So we have the state macro here gives us, if we have a subcomponent, we have a macro that gives us bidirectional synchronization via link, and we can have unidirectional synchronization via the prop macro. And this gives us very rich way of building applications, very detailed control about how state cascades and update. So that's just a very brief overview of the Cangjie on OpenHarmony development. It's still in development, and a lot more features will be added. And we're working on things like adding effects to do reactive programming, improving the state management system, making it more fine-grained, and so on. Adding actors to improve the concurrency support for this, and generally trying to integrate the Sanjay parts of this with the lower level operating system support for it, and so on. Okay. Yeah, so it's just a bit about how the macros expand. So we have a state variable here, and this expands into sort of pure Chanze syntax. We use props to define properties, and it, it's quite a straightforward expansion, but it makes it allows us to have a very readable, succinct syntax for it. And using these property values, this supports the automatic state update and so on. But I am a bit over time, I think, so I will skip over this. Right. Thank you very much. I hope I've given a good flavor of what Tanze looks like and how we can use it in the future and in OpenHarmony in particular.